Okay, so now we're on to lesson 114, connecting infinite limits and vertical asymptotes. So here's an intuitive idea of a positive infinite limit. So we're saying, what is the limit as x approaches a, as we get closer and closer to a from both the left and the right? What is the function doing? The function is increasing without bound from the left. So it's going to go to positive infinity, and from the right it's going to go to positive infinity as well. So from the left and from the right, they're both going to positive infinity, so the limit is infinity. Since infinity is not a number, you could also say the limit does not exist, and on the AP both would be accepted, but on a multiple choice they wouldn't have both of these as an option. They would have one of them as an option, so you don't have to guess. So for this intuitive idea of a negative infinite limit, so the limit as x approaches a, so as we get closer and closer to a from both the left and the right, the function is going to negative infinity for both. So the limit as x approaches a of this function is negative infinity, or we could say that it does not exist. The limit does not exist. All right, let's do a problem here dealing with infinite limits as x approaches infinity and what the limits are. Use the function f of x equals this rational function to evaluate the following. Evaluate the limit as x approaches 3 from the left of the function and the limit as x approaches 3 from the right of the function. You would notice that if we do plug in x equal to 3 into the function, we get an indeterminate form. So to get the limits as x approaches 3 from the left and from the right, let's go ahead and do a rough sketch of a graph. So step 1 is to, let's bring down the function, which is a rational function, and break it down into its factors. So this one's going to factor out to x and x, and it would be plus 4 and minus 2. This one breaks down to its factors of plus 4 and minus 3. You see here that x plus 4 with the x plus 4 cancels out. That's going to create the whole. So the new function f of x is going to equal to an equivalent function, x minus 2 over x minus 3, and we know that x cannot equal to negative 4. So that's where the whole is at here. And for what we're doing here, we don't really care about the whole. We care about the asymptotes, because we're trying to find the limit as x approaches 3 from the left and from the right. So we're more concerned about this. All right. So step 1 is to get the function, break it down, and then we want to, let's move this onto the side here. We want to find these vertical asymptotes, horizontal asymptotes, x-intercept and y-intercept. We want to get 4 things from this function. So the vertical asymptote is where, for here, where what x value makes the bottom of the fraction 0, and that would be 3. So it does have a vertical asymptote at x equal to 3. So how do we look for these horizontal asymptotes? So horizontal asymptotes, deals with leading coefficient powers, like in front of x is a 1. The coefficient for the highest power here is 1 of x. So it's a linear factor, and this is a linear factor. And when the leading coefficients, and then they have the same power, you just divide the numbers in the front. So it's going to be y is equal to, it's going to be at y equal to 1. We'll go more in depth talking about this in the next unit. But that's how it works. Okay, how do we find the x-intercept? To find the x-intercept, we set the y equal to 0. So to find x-intercept, set the y equal to 0. So the y equal to 0. So this is f of x is y. So that's going to be 0. So 0 is equal to x minus 2 over x minus 3. And solve for x. So we can cross multiply here. 0 times this is going to be 0. And then 1 times this is going to be x minus 2. Solve for x, you're going to get x is equal to 2. So x is equal to 2. To find the y-intercept, we do the opposite. Find the y-intercept. So to find the y-intercept, set the x equal to 0. All x is equal to 0. And solve for y. So in this equation, f of x is y, so we're going to say y is equal to x is 0, take away 2, over x is 0, take away 3. So there's going to be negative 2 over negative 3, so a negative divided by negative is positive, so it's going to be 2/3. So the y-intercept is 2/3. And with this information, we should be able to do a rough sketch of the graph. So we have the vertical asymptote is at x equal to 3. Okay, so we're going to draw a vertical asymptote at x equal to 3. We have a horizontal asymptote at y equal to 1. So we say y equal to 1, so this is y equal to 1. We have an x-intercept. We had x-intercept was, what was the x-intercept? Was it 2? So it crosses the x-axis at 2. And it crosses the y-axis at 2/3. So 2/3 is maybe down here somewhere. It should be like down here. And then it just approaches, no, this would be, let's see here. This doesn't go like this, can't go like that. That's negative 2/3. Okay, let me erase this. Erase, undo. 2/3 is up here somewhere. 2/3, it wouldn't have made any sense. That would be 1/2, 2/3. Okay, so now this makes sense. So this would be 2/3. It always approaches the asymptotes. So it always approaches the asymptotes. And more than likely these branches, they go diagonal. So the other one is going to go over here. You can actually input some numbers to figure out if it's on top or at the bottom. on this side over here. So if you plug in, say this is a 1, 2, 3, 4. If you plug in 4 here and plug in 4 here, you're gonna get 2 over 1, which is 2. So add 4, it should be 2. So it is on top. Okay, so now let's answer the question. What is the limit as x approaches 3 from the left? The limit as x approaches 3 from the left will be, as we get closer to 3 from the left, the function is going to negative infinity. Because this is 3. So this is going to be negative infinity. And the limit as x approaches 3 from the right, as we get closer and closer from the right, is going to be positive infinity. Just an added one that I'm going to give you here is limit as x approaches 3 does not exist. So when it's just saying 3, that's asking about both the left and the right. And so this one going down and this going up forever, this one does not exist. In reality, you could have just put down does not exist for all 3 of these, and that would have been fine. Okay, let's do one more. Find the limit as x approaches 3 from the right. So it's asking about, coming from the right. So here's another one that's like they written backwards maybe. They should have given it to you a little easier than that. So limit as x approaches 3 from the positive side is going to equal 2. So see, we're going to factor out a negative 1. And then we're going to have x minus 1 for this top one. So in reality it would be negative, then we have x minus 1, x minus 3. And then we're gonna get all these all these vertical asymptote, horizontal asymptote, x-intercept, y-intercept of the function. So the vertical asymptote again would be at x equal to 3. So the vertical asymptote is at x equal to 3. So put your vertical asymptote at x equal to 3. Horizontal asymptote, you got the number 1 here as the leading coefficient 1. 1 divided by 1 is 1, but we have a negative, so it's going to be negative 1. So y is equal to negative 1. So be down here. X-intercept, to find the x-intercept, set the y equal to 0. So this is equal to y, and that's equal to 0. When you cross multiply, this becomes 0. Cross multiply is going to be x minus 1 is equal to 0. In reality, it would be found on top, the x-intercept, the top of the fraction. So the x-intercept is at 1. So it crosses at x equal to 1. X. And the y-intercept set the x equal to 0. So that would be 0 minus 1, 0 minus 3, so it would be 1/3. So 1/3. The y-intercept is at 1/3, which is right here. So this one looks to be, how would you graph this? I said it approaches the asymptote, but it's going to be negative 1/3. See, one thing again that you got to be really careful. This is a negative. This is a negative. So if this is positive 1/3, we have a negative, so it's a negative 1/3. So then that wouldn't be it. It would be negative 1/3, which would be down here. And now this makes a little more sense as to always approaching the asymptotes when you draw the curve. So this is coming from the left side, but coming from the right, what is it going to do? So again, you want to just plug in a number. If we plug in again 4 and see what it's doing here on the right side of the vertical asymptote, plug in 4, that would be 3, and then that'd be 1, negative 3, because you got the negative on side, so it'll be negative 3. Negative 3 here, it will be here. So this thing is going something like that. So the limit as x approaches 3 from the positive side is going to negative infinity. So it's going to negative infinity as it approaches 3. Okay, so you guys do this by yourself, and then I'll give you the answer. You can pause the video. Okay, so here we go. So you factor, we said we factor it out. Turned out to be x minus 1 times x minus 1, which is x minus 1 squared. We find the vertical asymptote at x equal to 1. Now, this one right here, when you look at the powers, this is going to be an x squared here at the bottom. The highest power at the top is x. Whenever the bottom is a bigger power than the top, the horizontal asymptote will be y equal to 0, because this grows without bound. This one grows faster than the top, so it's going to be y equal to 0. We'll go more in depth with that later. So it's y equal to 0 whenever the bottom has a bigger power. X-intercept, plug in y equal to 0. So it's always found on top. So the x-intercept is going to be 3. X is 3 minus 3 is 0. X is 3. And the y-intercept, you said all the x's equal to 0. So it will be negative 3. Because it will be negative 3 over positive 1. So negative 3. And let's use those to graph. The x-intercept is 3, y-intercept is negative 3. With this information again, I think we're able to figure out what it does. I'm pretty sure it's always approaching the asymptote. So it's gonna go something like that and something like this. This one is gonna go down and then this one. So the limit as x approaches 1 looks to be negative infinity, or you could say it does not exist. Find the x values, if any, for which f of x equals x over x squared minus 1 is not continuous. If there's such a point, is it removable? So step 1 is to break it down into its factors. This one has 2 vertical asymptotes, one at negative 1 and at positive 1. Horizontal asymptote, again, the bottom is an x squared over an x. This is going to be y equal to 0. X-intercept, set the y equal to 0, it's found on top, so it'll be at x equal to 0. Y-intercept, set all of them equal to 0, so you're going to get what, x 0 at the top, then you got 1 times negative 1, you get 0 over negative 1, which is 0. So this is going to be 0 for the y-intercept. And then let's plot the points. So the x-intercept and the y-intercept are the same. And so now, how does the graph go? Which way is it going? Is it going like this, or is it going like this? Which way is it doing? You probably want to use another point. So let's use another point. Why don't we use something like positive number? Let's use 1/2 maybe, 1/2, and see what's the output for 1/2. So if this is positive 1/2. This is 1/2 plus 1, and you got 1/2 minus 1. So this is still going to be positive. It's going to be positive on top, some positive number. At the bottom is going to be 1.5 times some negative number. So this is going to be a negative. So a positive divided by a negative is a negative number. So this is going to go like this. Let's see. Yep, it does go like that. So it goes because this one has an output, some negative output, and they always approach the asymptote like that. So since it has asymptotes here and here, you didn't have to do like, we don't even need to graph this thing. We already know that, and whatever this other one does, what does it do on the left and the right? Okay, something like that. That it will not be continuous at x equals -1 and x equal +1, because there's no way for them to be continuous there. There's one negative infinity, positive infinity. So it is non-removable at x equal -1 and x equal to 1. We cannot make the function continuous at those two x values. As a result, the discontinuities are non-removable. Okay, we're done. See you next time.